All right, let's get going because we got a whole lot to cover and not a lot of time to cover it in. The first thing we covered today, and if you weren't in class, unfortunately, I don't think it's going to be as much fun for you. But we covered some things, and we said basically, is it possible to go from water to ice or liquid to solid? And if it is possible, what is the name of that process? And we said to go from liquid to solid, it is called freezing or freezing point. To get to the freezing point, you must subtract heat. So I'm just going to put this little negative in blue there. Now, it's also possible for me to go from a solid, from ice to water. And we call that the melting point. Again, none of these are very new. None of these are very tough. To melt ice, we need to add heat. None of us in here this year were shocked that we could go from a liquid to a gas. We've seen that in the kitchen before, and we call that evaporation, or you could say the boiling point. To reach evaporation, you need to add heat. And this is where I think things get a little new. We learned this year that water vapor can actually turn back into little droplets of water in a process that we know as condensation. Now, condensation is when water vapor rises up into the atmosphere and loses heat, turns back into droplets, and we know that condensation is cloud formation. Now, you'll notice a majority of our stuff is in the middle and on the left-hand side of our chart. And we start to wonder, is it possible for water vapor to go straight into ice? Can it turn from gas to ice without ever going through the liquid phase? And we saw today, when we watched that Frosty time-lapse video, that it can. In a process called desublimation. Now, if we're turning something into ice, obviously we are taking away heat. One thing that we did in class today that I think was a lot of fun, hopefully it was for most people, we turned something that was solid straight into a gas in a process known as sublimation. And when we were sublimating the dry ice, and you can look up a video of dry ice, you can see what we did in class. We added heat, and we noticed that dry ice went from a solid directly into a gas. We had a good time with that. Now, this is a chart you need to think about that you kind of need to know. It will come up very often, and it's going to start coming up even more when we start talking about chemical and physical changes. It'll come up at the beginning of third quarter when we talk about heat exchange. So evaporation, condensation, freezing and melting, sublimation, and desublimation, which sometimes they list as deposition. But these two don't show up nearly as often as they could. Switching gears, and I know it's very weird to switch the gears in a video. Obviously, we pack some things up and put some things away in class and take a little, like a brain break, but we can't do that in a video, so we're going to move on. Parts of the whole, or when we're talking about matter, parts of matter and the whole of things. As we said in class at the very beginning, and this is the same slideshow for us at home that we did in class. This concept is very easy if you pay attention and follow along. Of course, there are some misconceptions that people can make, and there are some mistakes you can make here and there because there's a lot of math involved in this. But as a whole, I think this concept is actually fairly simple. So in class today, I broke out a Hershey bar and a scale. And I put the Hershey bar out of the wrapper on the scale, and shocker, in all three classes, it weighed 1.55 ounces. I say shocker for two reasons. Number one, that they weren't giving away any extra chocolate. There was no 1.56. Hershey's is not giving anything away for free. Also, a little shocked that there weren't any 1.54s or 1.53s because they'd be trying to rip us off all the time. But maybe they know that there's dorky science teachers and we would get on to their ruse of ripping us off of tenths and hundredths of ounces. And that would make all of us angry because we all love our chocolate. Except for one person in class today who said she hates chocolate. But if I take this whole Hershey bar and I weigh it and it's 1.55 ounces and I break it into these little bitty pieces that they've segmented off for me. My question was this. I have 12 pieces. And I would understand if someone said, well, Mr. Bullens, you went from 1 bar to 12 pieces. 12 is more than 1. The bar would weigh more. Then I can understand someone in the same class looking at me and saying, well, no. You had a big bar. You broke it into smaller pieces. It's going to actually weigh less. And when I presented the class with this question, I think a lot of people had the same questions running through their mind. But in all 3 classes, someone eventually raised their hand and said, Mr. Bullens, both are going to weigh the same because those pieces are what made up the bar. And I thought, well, that's a pretty interesting way to think about it. Let's find out. Sure enough, when I broke the pieces apart and weighed them, they weighed exactly 1.55 ounces. We had not gained any chocolate. We now had lost any chocolate. It was the same amount of chocolate that was in the original bar. But then I got a bright idea. I also like making messes. I brought a cheese grater to school, and I said, wait a minute. If I grind this down into like fine little shavings of chocolate, and somebody said it looked like lots of ants running around inside of the bowl I scraped it, or grated it into, and I would agree with that. Maybe if I break it into super small pieces, that will make a big difference. And then there were some people saying, yeah, Mr. Bones, if you break it into pieces that small, it's certainly going to weigh less. Same kids in every class said, no, I disagree. It's still the same amount of chocolate that was originally in that bar. As a matter of fact, if you wanted to melt all those shavings down and put it in the mold, it would be the same candy bar. We could probably make it the same candy bar again. So we measured to find out. And sure enough, the grated chocolate weighed 1.55 ounces. And we were thinking like, well, what does this mean? Does it mean anything yet? And we weren't sure about that. Because we thought it could be a coincidence, but maybe it's not. So we broke out some Legos. Maybe it's a chocolate thing, we thought. We had Legos. We built small little structures similar to the one you see here, and we weighed it. And let's just say it weighed 3.5 ounces. And then you could pretend that your baby brother, baby sister comes in the room, and they destroy your brand new built Legos, and you're looking at this pile of Legos. And so we weighed the pile of Legos after we had broken down each person's build. And shockingly, the pieces of Legos weighed exactly the same as the structure. So then I got to thinking, there's got to be a way that I can, I got to find the exception to the rule here. And we thought we had figured it out. We measured an ice cube, and it weighed 2 grams. And we thought, certainly, if I melt this ice cube down into water, right? Ice weighs more than water. It has to. That seems right. So we melted the ice cube and poured that water into the same cup that the ice cube was in, and we weighed it. And when we weighed it, it weighed exactly the same as the ice cube. And we all thought, well, that's it. We give up. We can't find a trick to this. So we thought, I think we've come up with a scientific statement. And we wrote down this right here. The sum of all the pieces is equal to the whole. You should probably pause the video and take a time to write that down. The sum of all of the pieces is equal to the whole. And most people started nodding. Yeah, this is easy, Mr. Bones. This makes sense. So we tried out a question. If a 100-kilogram rock is broken into 5 smaller rocks for a garden, what is the total mass, again, the total mass of all 5 rocks? If I have a 100-kilogram rock and I break it into 5 pieces, I'm tempted to say 100 divided by 5 is 20. But number one, it doesn't say anything about equal pieces. Number two, it just says how much is the total of all 5 rocks. Well, if it was a 100-kilogram rock, I can't get more kilograms out of it. So I think it weighs exactly the same. And that would be correct. When we have the rock, we have all of the stuff inside of the rock, all the matter. Even though we break it into 5 different pieces, we haven't lost any of the matter. We're not losing anything. So when you put all the pieces together, it equals the whole. Remember, parts of the whole. The sum of all the parts is equal to the whole. Second question, though. What if you have a bucket of snow that weighs 20 kilograms and it melts? What will the bucket and the water weigh? Well, again, that's like the ice cube. It weighed the same, so I'm going to guess the same here. And sure enough, it is exactly the same. Just because you change state doesn't necessarily mean you've lost anything, because you still have the same amount of molecules of water in the snow and in the bucket of liquid water. Here's the one that got a little tough for us. What if I have this sandwich? Okay, I'm not breaking something down. I'm actually building something up. How would I find the total? And some people said, well, Mr. Bowens, if you weigh this tomato and this bread and this bread and this lettuce and this bread all together and you put all those numbers together, you would get the answer. And I said, that makes sense, so let's try it. So we did, and we said Elsa's making a grilled ham and cheese sandwich. She used 20-gram slice of cheese, so that was 20. 40 grams of sliced ham, that's 60. And 15 grams of bread, that's 75. But when almost all of us clicked 75, we got the question wrong. And here is the reason why. 20-gram slice of cheese, check. 40 grams of ham, check, that's 60. And two 15-gram slices of bread, that is 30, and 60 plus 30 is 90. We got tricked by a multi-step word problem, not by the science that we were doing today. Now, what about salt? When I pour salt in water, the salt disappears. Well, it dissolves, but it disappears. Certainly that won't weigh the same. It does weigh the same. If you think the salt is gone, try dumping the salt in the water, stirring it until it dissolves, and then drinking the water. If you taste the salt obviously is still there. So 10 and 10 is 20. And we found out that that was actually one of the easier ones that we did today. So Maya adds 6 grams of sugar to a bottle containing 14 grams of water. 6 plus 14 is 20. Certainly it can't be that easy, Mr. B. It is that easy. And we learned that in class today, that it is. And it was at this point that we said, all right, okay. If you're telling me it's easy, then I get it. I get it now. This is easy. Let's keep on rolling. So we did a very quick quiz to see if people understood everything. The mass of a piece of copy paper is 10 grams. Katie tears the paper into 4 equal sections. What is their combined mass? It does not say 10 divided by 4 is 2.5, which I think should have been one of the answers down here. It's a 10-gram piece of paper. I tore it to shreds. It still weighs 10 grams. What about a jeweler melting gold? So they melt gold to make jewelry. As the gold melts, does the mass increase? Well, I'm certainly not getting more gold. It doesn't decrease. This makes no sense. You're not destroying the gold. The mass stays the same. You're not gaining. You're not losing anything. 10 grams of water, 5 grams of salt. Certainly, Mr. Bowens, 10 plus 5 is 15. Is it that easy? It is that easy. This is not one of those overly difficult things where there's lots of tricks and triangles and things to draw. You've got this. A teacher adds 2 grams of chalk to 25 grams of vinegar in a tightly sealed jar. That will come into play tomorrow. The chalk and vinegar react and gas bubbles form. What's the total mass of the jar's contents after the reaction? Well, 2 and 25 is 27. Holy cow, Mr. B, I think I can actually do this. And you can. It is that easy, and that was the most common score today. Overall, if you got an 88, then you were probably right along with most people. Anyway, I hope this made sense. I know it's a super quick video. Of course, if you have questions, we'll be going back over this again in the morning, and then we'll take our quiz and knock the rest of the day out, and we'll be 1 week closer to our vacation. Good to see you, kids. Smash the like button.